These functions they call hyperbolic functions, and the hyperbolic sine of x is defined as e to the x minus e to the negative x divided by 2. And the function hyperbolic cosine of x is defined as e to the x plus e to the negative x divided by 2. And then the hyperbolic tangent of x is defined as the hyperbolic sine of x divided by hyperbolic cosine of x. And then the hyperbolic cosecant is 1 over hyperbolic sine. And then the hyperbolic secant is defined as 1 over hyperbolic cosine. And hyperbolic cotangent is defined as hyperbolic cosine divided by hyperbolic sine. And this is what the graph looks like. This is the graph of hyperbolic sine of x. And this is the graph for hyperbolic cosine of x. And this is the graph for hyperbolic tangent of x. And now let's get the derivative for these hyperbolic functions. And so recall that the derivative of e to the x is just e to the x. The derivative of e to the negative x is e to the negative x. And then this is the chain rule right here. And so let's do the derivative of the hyperbolic sine. So the derivative of the hyperbolic sine of x and hyperbolic sine of x is defined as e to the x minus e to the negative x divided by 2. And so let's rewrite this as 1/2 times e to the x minus 1/2 times e to the negative x. And then the derivative of 1/2 e to the x will be 1/2 times the derivative of e to the x, which is e to the x. The derivative of 1/2 e to the negative x will be 1/2, and then the derivative of e to the negative x is e to the negative x times -1. So altogether we get 1/2 e to the x plus 1/2 e to the negative x. But 1/2 e to the x plus 1/2 e to the negative x is the hyperbolic cosine. And so if we look back at the definition here, hyperbolic cosine of x is defined as e to the x plus e to the negative x divided by 2, which is the same as 1/2 e to the x plus 1/2 e to the negative x. And that's what we have right here. And so the derivative of hyperbolic sine of x is equal to hyperbolic cosine of x. Recall that the derivative of sine of x is cosine of x. And here we have derivative of hyperbolic sine of x is hyperbolic cosine of x. And then the rest of the other hyperbolic functions, they will be like this. The derivative of the hyperbolic sine is hyperbolic cosine. Derivative of hyperbolic cosine will be hyperbolic sine. Derivative of hyperbolic tangent will be the hyperbolic secant squared. The derivative of hyperbolic cosecant will be negative hyperbolic cosecant times hyperbolic cotangent. And the derivative of hyperbolic secant will be negative derivative of hyperbolic secant will be negative hyperbolic secant times hyperbolic tangent. And the derivative of hyperbolic cotangent will be negative hyperbolic cosecant squared. Here we have the function f of x equal to hyperbolic sine of 7x, and we want to find the derivative. And as we have just seen, the derivative of the hyperbolic sine is the hyperbolic cosine. And so the derivative here would be just the hyperbolic cosine. Now, if we just have hyperbolic sine of x, then the answer would be just hyperbolic cosine of x. But here we have the hyperbolic sine of 7x, so it would be hyperbolic cosine of 7x, and then the chain rule is we have to multiply by the derivative of the 7x. The derivative of 7x is just 7, so we get 7 times hyperbolic cosine of 7x. And that's the answer. Here we have the function f of x equal to hyperbolic secant of 5x squared plus 8, and we want to find the derivative. The derivative of hyperbolic secant is negative hyperbolic secant times hyperbolic tangent. And so here we get negative and then to be secant, hyperbolic secant of 5x squared, and then plus 8, and then times hyperbolic tangent of the 5x squared plus 8. And then the chain rule, we have to multiply by the derivative of the 5x squared plus 8. And then the derivative of the 5x squared plus 8, this will be just 10x. And this is the answer. Here we have the function 1/2 times hyperbolic cosine of 15x minus x over 2, and we want to find the derivative. And so derivative of hyperbolic cosine is hyperbolic sine. So here we get 1/2. And then the derivative of hyperbolic cosine will be hyperbolic sine of 15x. And then we have to multiply the chain rule. We have to multiply by the derivative of 15x. And this is the same as 1/2 times x. 1/2 times x, so the derivative will be just 1/2. The derivative of 15x, which is 15. One half times 15 is 15 halves. And this is the answer. Here we have the function of inverse, tangent inverse of hyperbolic sine of x, and we want to find the tangent line at the point 0, 0. And so let's look at the graph. And this is the graph right here. This is the graph of tangent inverse of hyperbolic sine, and this is the point 0, 0, and this is the tangent line that we're looking for. And now to get the tangent line, first we have to get the slope of the tangent line. And the slope of the tangent line will be it'll be the derivative at 0. And recall that the derivative of tangent inverse of x is 1 over 1 plus x squared. But here we have tangent inverse of hyperbolic sine of x. And so the derivative of tangent inverse is 1 over 1 plus x squared. But here we have tangent inverse of hyperbolic sine of x. So in the place of x, we put hyperbolic sine of x. And then the chain rule is we have to multiply by the derivative of the hyperbolic sine of x. The derivative of hyperbolic sine of x is cosine of x. Hyperbolic cosine of x. And now we need the slope of the tangent line, which is the derivative evaluated at 0. So right here we get 0. And then we can use a scientific calculator, and then we can evaluate hyperbolic sine of 0, and it beats 0. And hyperbolic cosine of 0 will be 1. And then altogether we get 1. So the tangent line passes through the point 0, 0, and it has a slope of 1. And therefore equation of tangent line would be y minus 0 equal to the slope and then x minus 0. And then all of this will become y equal to x. And so the equation of the tangent line is y equal to x.